so here we go. So guys, parallel lines are lines that never intersect. What is, so kind of the way that, one of the shorthands that we use when I describe parallel lines are these two little slanted lines that go sideways, okay? You got two little parallel lines right there that go sideways. So that is the shorthand. Instead of having to write out the word parallel every time, I like to write the little side slashes, okay? You're going to see this a lot in geometry. Okay, now algebraically, how do we know if two lines are parallel? Well, I'm going to tell you guys, it's going to have to do with their slopes. So algebraically, they have the same slope. Okay, and not like kind of the same. I'm talking the exact same. So if my original equation would be y equals 2x plus 1, we'll just go with that. A parallel line to that would be y equals 2x plus 7, or y equals 2x minus 5, or y equals 2x minus 7. Because what matters about them being parallel? The slope, okay? So if we have two lines that have the exact same slope, then they are parallel. Now, what can you guys tell me about perpendicular lines? How can we define perpendicular lines? When something is perpendicular. If you were going to explain it to a grade school kid, my second grade daughter, she was like, what's a perpendicular line? How would you describe it? Yeah? Will, go for it. Ooh, they do intersect with one another, okay? But they intersect in a very special way, okay? So perpendicular lines are lines that intersect. They don't necessarily have the same intercept, but they do intersect, and they intersect at a 90-degree angle, or they intersect at a right angle. You're going to see this a ton when you get to geometry, because lines that are parallel have very special relationships, and lines that are perpendicular have special relationships. And the symbol that we use for perpendicular lines is this kind of upside down capital T, because that creates a right angle. And guys, you'll notice whenever you do perpendicular lines, if lines are truly perpendicular and form a right angle, then you draw this little square kind of in the corner, and that shows that they're right angles. Now, they don't have to be exactly up and down. They could be lines that have, a slope that is not 0 or undefined. So those are also perpendicular lines. Lines that would not be perpendicular would be lines if they cross like that. You see how that doesn't make a right angle? So yes, they intersect, cool, but they're not perpendicular, they're not parallel, they're just neither. Okay, so we're going to be talking about two special relationships, parallel and perpendicular lines. You guys good with that? Okay, so algebraically, how do we know if the two lines are perpendicular? Well, guess what? It's still going to have to do with your slope. But this time, what it's called is they have, and I use the term negative reciprocal slopes. Okay? So sometimes people say opposite reciprocal, which is totally fine. I like the term negative reciprocal. It means the same thing. And you're like, cool, Miss Humanek, but what's a negative reciprocal slope? So I'm going to give you again that original line. Let's say my original line was y equals 2x plus 1. Well, a perpendicular line would be y equals negative 1/2 x, and then we'll say plus 7 again, okay? So in this case, if you take a look at my two slopes, this is 2, that's negative 1/2. So what we did was we flipped the fraction and we make it negative. Now, but you're like, Miss Humanek, but 2 is not really a fraction. But it is if we make it 2 over 1. Does that make sense, y'all? So we have 2x plus 1 equals, and then that would be one of our equations, and a perpendicular line to that would be y equals negative 1/2 x plus 7. Now, to show you guys that I'm not just bluffing here, I'm going to actually graph these for you, okay? So let's graph this one. Y equals 2x plus 1, and y equals 2x plus 7. Now, hold on just a second. I'm going to make sure. Okay, so these are what my two parallel lines look like. That looks pretty good, right? You can graph them. You can see, yes, they are truly parallel. Okay? Now, in my calculator, I'm now going to graph my perpendicular lines. I'm still going to do 2x plus 1. And then I'm going to put in alpha y equals, let's see here, negative 1/2 x plus 7. So when I hit graph in my calculator, do those lines look perpendicular to one another in this calculator? No, because guys, you have to remember, when you're using a graphing calculator, the screen for the graph it's a rectangle, not a square. So it kind of gets pulled sideways. So the way you can make sure they're actually perpendicular to one another is you have to change this guy to be a square screen instead of a rectangular screen. Does that make sense? So if you go zoom square, which is 5, so I'm going to scroll down to 5 here, then it actually makes the even. Now, do those two lines look actually perpendicular to one another? Yes. So you have to be careful when graphing these on the calculator. If you're going to graph with the standard zoom, because it's a rectangle screen, it always pulls it, it stretches it horizontally. Does that make sense, y'all? So if you want to see it accurately, you have to go to that zoom square, that Z5 there, that Z square, and that actually makes it look nice and truly perpendicular. Because guys, you'll notice if I turned my graph, does that actually look like a right angle? Yeah, it does. Okay. Now, you don't just want to go by the way it looks, but this is a good check. Does that make sense? You guys tracking with me? Okay. Now, so let's talk about negative reciprocals. How can we actually find a negative reciprocal? Well, guys, let me give you an example here. If my slope is 3/4 and I want a negative reciprocal, then I would flip my fraction, so that would become 4/3, and make it negative. Negative 4/3. Okay? What about number 2 here? What do I need to do? If I need to flip my fraction, that becomes negative 1/2. Exactly. Okay? Number 3, we're going to flip our fraction. 8/7. Ooh, but it was a negative, so now what's going to happen? That's a positive 8/7. Y'all see that? It flips the sign and it flips the fraction. All right, number 4. Well, 1/1, if we flip the fraction, it's still 1/1, but then we have to make it negative, so it just becomes negative 1. So these are all good reciprocals here. Negative 4/3, negative 1/2, 8/7, negative 1. What would be my reciprocal slope to a 0 slope? Ooh, parallel would be 0, right? Because remember, this is a horizontal slope. So yes, I heard a couple people say this. The reciprocal to that would be undefined. Because guys, a 0 slope is kind of like saying 0/1. So if we flip that to negative 1/0, well, that would be undefined. All right, guys? So guys, whenever you see slopes that are 0 or undefined, you got to remember that Hoy and Vux, okay? Hoy is always perpendicular to Vux, and Vux is always perpendicular to Hoy. All right, so on this first page, what I want us to do is we are just going to see if these lines are parallel, perpendicular, or neither. All right? So let's check it out. So what do we need to know if we want to identify if they're parallel, perpendicular, or neither? What do we need to look at? The slope. So we need, you can kind of write this over here, we need to look at the slopes. And depending on what they tell us, We will see if they're parallel, perpendicular, or either. Well, this first one's really nice because it's already in slope-intercept form, isn't it? So what is my slope of this first equation? 7. And I'm not sure why we jumped to number 9. We went 1, 2, 3, 4, 5, 9. Cool. Okay, so that's 7. And then what is the slope in my second equation? It's also 7. So if my slopes are exactly the same, what does that say about my line? They are parallel. So this is where you can write the word parallel, or if you want to be all fancy, you can just do the little symbol and just write parallel. Y'all feel good about that? Will, do you still not have the notes? All right. So here we go. Now, Adrian, do you have your notes still? Do you need a new packet? Alright guys, so here we go. On this next one, this one won't be so bad because it's still in slope-intercept form. What is my original slope on this first line? It's 4/5. What is my slope on the second line? Negative 5/4. So if we're looking at these two, what can we, do these have a special relationship? Well, they're flipped. Is it negative as well? So what do we know that's true about these lines? Are they parallel, perpendicular, or neither? These guys are perpendicular. So this is where you can go in here. You can write the whole word out, perpendicular. Yikes, that's a long word. Or you can write the little special symbol of that upside down capital T. Okay? Now, number 11. Let's take a look at number 11 here. What is my slope for number 11? M equals negative 1/3. What's the second slope here? M equals 1/3. What is true about these? Do these have a special relationship? No, they're not the same. They are the negative of one another, but they're not the reciprocal. So this one right here is neither. Does that make sense, y'all? That one's neither. All right. Now we're going to take a look at number 12. Number 12, can we easily identify what the slope is for number 12? No, we're going to need to get them into slope-intercept form. So guys, today we're going to be doing a lot of converting to slope-intercept form. It's like that homework that we just did was really useful for that. So we're going to do a lot of converting into slope-intercept form. So we're going to subtract x from both sides on this first one. We have 6y equals negative x plus 30. Okay? Now we divide both sides. We divide everything by 6. So my equation is y equals negative 1/6x plus 5. Do y'all feel good about that for the first equation? Okay, for my second equation, the x is already over here. So what's the only thing I got to do? Just divide by 3. So I'm going to divide by 3. So I'm going to say, okay, well, my y is equal to 6x minus 2. So now I look at my two slopes here, and what do I notice? I have a negative 1/6, and I have a positive 6. So are my slopes parallel, perpendicular, or neither? Perpendicular. So because I don't have a lot of room, I'm going to do my little fancy sign there. Do y'all feel good about that? So it is, these are perpendicular lines. Okay? So what I want you guys to do right now is I want you guys to do 13, 14, 15, and 16. All right, guys? Some of these are already in slope-intercept form. Like on 13, one of them is already in slope-intercept form, so you only have to change that one equation. You don't have to change both of them. 14, they're not, we have 2 in standard form. 15, they're both in slope-intercept. And 16 is kind of special. So what I want you guys to do is I want you guys to work on those guys real quick on your own, and we are going to go over them in just a moment. Okay, so here are the answers to 13, 14, 15, and 16. If you want to pause that, then you can go ahead and do that, and you can check your answers and make sure they're correct. All right. Now we're going to move on to page 9. Okay, so if we look at page 9 here, now we are going to be practicing writing our perpendicular and parallel lines given certain points. So guys, today we're going to get to use point slope form, everyone's favorite form. Okay, so guys, check this out. The important thing to remember is that your parallel lines have the same slope. The perpendicular lines have those negative reciprocal slopes. I love the word reciprocal. It's like, say it 5 times fast. Reciprocal, reciprocal, reciprocal. It's like, it's just hard. It starts to, my tongue's, twist up my tongue. Okay, so now guys, for our parallel examples, what we are going to see here is, remember, and I'm just going to go ahead, I'm going to write that in there. My parallel lines have the same slope. Okay, because that will help me. Okay, so what I'm going to do is, guys, I'm going to look at my original equation. We want to write an equation that passes through this point and is parallel to this original line. So, y'all, what is my original slope? My original slope is what? -4. Okay? So then, if my original slope is -4, I'm going to draw a little arrow. I'm going to say, what is my parallel slope? It is also going to be -4. Do you guys feel good about that? So I kind of like to say, okay, if my original slope is -4, I draw a little arrow and I say my parallel slope is also -4. Do y'all feel good about that? Okay. And then the point that we are going to be using is this -2, 7. So guys, if I have my slope and I have a point, can I write point slope? Absolutely. So I'm going to go ahead and write my point slope form here. And I'm going to say my new line is going to be y minus 7 is equal to the slope, which was what, -4? And then parentheses x minus, but if it's minus -2, it's really +2, right? Do y'all feel good about that? So we just turned it into point slope form. Now that we turned it into point slope form, is this fairly simple to convert to slope intercept? Yes. We just need to distribute and then add. So we're going to say -4 times x is -4x. -4 times +2 is -8. So y minus 7 equals -4x plus 8. So now I'm going to add 7 to both sides. So we have y equals -4x minus 1. You guys feel good with that? Y equals -4x minus 1. So this would be my parallel line to y equals -4x plus 1. They have the same slope, and if we graphed both of these guys, we said -4x plus 1 and -4x minus 1, we would see they are lovely parallel lines. They're very close to one another, but you can see that I wish I could zoom in there. No, that's going to look horrible. I'll leave it down. They are very, very close to each other, but they are parallel. They're just like right up next to each other. All right, guys, y'all feel good about that? All right. I like this. Oh, by the way, did y'all know we're all going to get new calculators? So each class is going to get a set of these little fancy ones that have like the colors. So you'll have 2 different colors for your graphs and stuff. I'm really excited. It's like we're supposed to get them around Christmas. It's like a really good math teacher Christmas present, isn't it? So anyway, I'm really excited. All right, so write the equation of this line that passes through this point. So we're given a point, and we want it to be parallel to this line right here. So the problem is, do we have the slope from this line? No. So we have to turn it into slope-intercept form to find what our slope of our original line is. So I'm just going to rewrite it over here. X minus 3y equals 9. I'm going to subtract my x from both sides. So that's -3y equals -x plus 9. Divide everything by -3. So I have y equals positive 1/3 x, because a negative over a negative gives me positive. 9 divided by negative 3 is minus 3. Cool. So this is my original line. So what is, if my original line is 1/3, has a slope of that 1/3, what is my perpendicular slope going to be? So what is that perpendicular slope going to be? It's also going to be 1/3, isn't it? So, I'm sorry. We are looking at parallel. Y'all, correct me, okay? So, I'm just going to rewrite this over here. So, my parallel slope is also 1/3. We know that parallel slope is 1/3. And we know our point is what? 3, -1. So, if I have this information, can I put it into point slope? I sure can. So, I'm going to go over here. I'm going to say, okay, y minus -1, so that becomes y plus 1 equals my slope, my m, which is 1/3 parentheses x minus x1, which is 3. You guys feel good with that? Awesome. So now we take this and we simply convert it and we say, cool, well that's going to be y plus 1 equals 1/3 x. 1/3 times -3 is minus 1. We add 1 to both sides. Wait, what did I do wrong? I don't add 1. What do I do? I did something wrong now. I subtract 1. I subtract 1 from both sides, and we get y equals 1/3 x minus 2. Okay? So when I do that, I can graph both of my lines, the 1/3 x minus 3 and 1/3 x minus 2, and we would see that they are parallel to one another. Do y'all feel good about this? So guys, honestly, today we're not necessarily using a lot of new skills. We're just having to realize, are they parallel or are they perpendicular? You guys have done the point slope thing before. You have found slope, but now we just have to see about the whole parallel and perpendicular thing. So guys, remember, with perpendicular lines, I'm going to write my little symbol here. My slopes are negative reciprocal slopes. Okay? So we are thinking about negative reciprocal slopes. So for this first one, we're looking and we're given a point, our 4/3, and we know that it's going to ask us if it's perpendicular. So we're thinking negative reciprocal. When you see the word perpendicular, think negative reciprocal. Okay? When we see that, we know it's going to be negative reciprocal, and this is our line. So guys, what is my original slope? 2. Just 2. My original slope is just the 2. So my perpendicular slope, so I'm doing my little perpendicular slope, would be equal to -1/2. So if we have our perpendicular slope and we have a point, can we put it in point slope form? Absolutely. So this becomes y minus 3 is equal to m, which is now -1/2, parentheses x minus 4. Do y'all feel good about that? So now we are just going to convert this into slope-intercept form. So I'm going to distribute my -1/2 to get -1/2 x plus 2. Then I will add 3 to both sides. I'm going to write it over here as y equals -1/2 x plus 5. Y'all feel good about that? So the biggest thing you have to do is recognizing it there. All right, now we're going to do this one. But for this lovely guy here, 5x plus 3y equals -21, do we know the slope? We don't. They tell us that we want what's going to pass through this point, and they want it to be perpendicular, but we don't know the slope. We have to convert it to know our slope. So I'm going to go here. I'm going to subtract my 5x from both sides. And I'll get 3y equals -5x, oops, not plus 21, but minus 21. Are you guys good with that? Then we divide everything by 3. And we get y equals negative 5/3 x minus 7. So that's our original equation. So what is my original slope here? Negative 5/3. So what is my perpendicular slope going to be? Yeah. So my perpendicular slope is equal to positive 3/5. So if we have our perpendicular slope and we have our points, can we do this in point slope form? Absolutely. So we go here, we say y minus 1 is equal to m, which is 3/5, parentheses x minus negative 5, so that's just x plus 5. Then we go here, we're going to distribute. We have y minus 1 equals 3/5 x. 3/5 times 5 is plus 3. Then we add 1 to both sides, and we get y equals 3/5 x plus 4. So this would be our line that would be perpendicular. Do you guys feel pretty good about these? All right. Now, one thing that I want to show you guys on these is you can do this kind of the algebra method. You can also do this with just with a graph. Okay? So I'm a numbers person, so I like the number method. I use these numbers. But guys, let's say you're looking at these. You can graph the point for 3 and then use that point to move your slope and find that y-intercept. Okay? So I'll show you guys an example of that on the board, but you can do this just using a graph. Okay? You can also do this using a graph. So on this last page here, for page 10, what I want you guys to do is I want you guys to go ahead and I want you to do one from each row. So pick 5 or 6, pick 7 or 8, pick 9 or 10, and pick 11 or 12. If you just want to do all the odds, that's fine. If you want to do all the evens, that's fine. And then you guys can check your answers there. So pick one from each row. I'm going to flash the answers up here for just a second for our folks watching at home. So I'm going to flash these answers up here. They can pause it and take a look at these. And so if you guys want to take a look at this, that will help you guys as you guys are doing that. If you are in class, please don't look at the answers right now, okay? These are just for the kids at home. So you can check your answers against these. But please, please, please make sure you actually attempt either one from each row. Okay, you don't have to do all 8. I just want you to do 4.